Hello everyone, in this tutorial I will take you through this hybrid medium access. So this hybrid medium access, as the name itself indicates, it should make use of two or more protocols. That is only the advantage part of two or more protocols. So thereby, as the name itself indicates, hybrid medium access. So here it makes use of both contention based as well as reservation based protocols, and provide different advantages and disadvantages. And the very first point over here is contention based protocols require significantly less overhead. Protocols results in high channel utilization in cases where there is low contention. As nodes increases, channel contention increases and decreases utilization, that is the channel utilization, and this leads to increasing collision. Reservation based protocols provide scheduled access to each of the node and decreases collision. So reservation access does that, whereas this results in high utilization when the computation is high, but also in latency, and also contributes for latency and overhead. So trade-off between access capacity and energy efficiency is happening over here between contention based and reservation based protocols. Aim of this hybrid medium access is to leverage the trade-off introduced in the channel allocation by combining random access schemes with reservation based TDMA approaches. So this results in ZebraMAC. So ZebraMAC provide an adaptive operation based on the level of contention, combines the advantages of each scheme in a hybrid MAC solution. Communication structure of ZMAC still relies on time slots similar to that of TDMA based solution. Each slot is tentatively assigned to a node. The difference between TDMA based solution is that each slot can be stolen by other node if it is not used by its owner. ZMAC behaves like CSMA under low contention, and it behaves like TDMA under high contention. So here this can be remembered by remembering CL. So ZMAC behaves like CSMA under low contention, remember CL, casual leave, and whereas it behaves like TDMA under high contention, and remember TH. ZMAC protocols of ZMAC consists of a setup phase and a communication phase. The setup phase has four main components. First one is neighbor discovery, second one is slot assignment, local frame exchange, followed by global time synchronization. Neighbor discovery is performed once by each node to gather information about its two-hop neighborhood. So it always does this two-hop neighborhood because of a reason, and we'll be going through that. So collisions in wireless channel affect the two-hop neighborhood of each node because of hidden terminal problem. So because of this hidden terminal problem here in network discovery, each node should be having information related to its two-hop neighborhood. Slot assignment is performed. The second component, that is slot assignment, is performed by DRAND protocol, which ensures a broadcast schedule such that each node is assigned a slot that will not coincide with the slots of its two-hop neighbors. DRAND first creates a radio interference map of the network, followed by nodes that can interfere with each other are connected by bidirectional links. Slots assignment is performed iteratively according to the map. So as you can see, here is a case where C needs to assign a slot to itself. So here we are having this node C, and these are all the other nodes distributed in this fashion. This is the network topology given, and C has to assign itself a slot. So what it does is, what this hybrid ZMAC does is, first thing it does is neighbor discovery. So first what it does is, it makes use of DRAND, that which creates radio interference map. So this is the radio interference map, that which has directed lines, directed bidirectional lines connected between all the nodes that which are in the vicinity. So this is the radio interference map. Then because C wants a slot to itself, so what it does is, it transmits request message. It will broadcast request message to all the other remaining nodes, and after receiving this request node, the other nodes will reply back to the node C as grant. So receive grants. Node C indicates that the particular slot is reserved by broadcasting release message. So then node C will publish release message indicating a particular slot is reserved for broadcasting, and each immediate neighbor also communicates this slot to each 2 hop neighbors. So here, when this release message receives all these nodes, so this D is at 1 hop. So this D then reroutes the release packet to the 2 hop nodes that which are in the vicinity, that is node E and F, 2 hop release. After that, if at all, if there is any conflict with the slot selected by node C, this is indicated by reject message after the request broadcast. So here the node D has an overlapping time slot, so because of which it is passing reject, but whereas A and B are not having any overlapping time slot, so thereby they are passing on grant. So because this involves reject, it is receiving reject as its message from D, so there won't be any allocation. So if node C does not receive grant messages from all its neighbor, it broadcasts fail message. So ultimately it is broadcasting fail message to all its neighbor. So this is how the scheme works. There is this node C that which wants to ultimately communicate with the sink, so thereby it needs a slot. So what it does is, it first passes a signal called as ECN, where ECN is an acronym for explicit contention notification. When this message is passed, the other remaining nodes will halt stealing the time slot from its neighbor. So what happens here is, first C will pass ECN onto all the other nodes, and because A and B are not falling within the routing path to the sink, so they will discard it. They will discard ECN here, but whereas because node D falls in the routing path, it will not discard it, and in turn this D will also pass that ECN onto node F as well as node E, such that node E and F will not participate or will not compete during C slot. So forwarding of ECN for the 2 hops, and when these ECNs are received by D, F and E, they will enter into a state called as HCL, that which is an acronym for high contention level. The nodes receiving ECN message switch to high contention level mode. Nodes in HCL mode of a specific node do not compete for slots owned by that node. As a result, contention decreases on the path towards the destination or the sink. So this is how hybrid ZMAC actually works. Thanks for watching.